Good afternoon. I suggest that we open this SBSTA-IPCC special event on the special report on the ocean and cryosphere in a changing climate. And the aim of our special event this afternoon, as yesterday on the special report on climate change and land, is to unpack the new scientific knowledge and key findings in the special report on the ocean and cryosphere in a changing climate. So I'd like to, first of all, to thank my co-chair, Ho-Sung Lee, chair of the IPCC, and we have organized this afternoon's event between the SBSTA, which I chair with the help of the Secretariat, and of course the IPCC under the responsibility of Ho-Sung, with the support of the very able Secretariat also of the IPCC. And I'm very grateful also to welcome two distinguished colleagues to the platform who will take part in our opening and welcome session, and then we'll move into the substance in a short while. And I want to thank Andrés Couve, the Science, Technology, Knowledge and Innovation Minister of Chile, the presidency of the COP, who will say a few words in a few minutes, and also Ovais Sarmad, the Deputy Executive Secretary of the Convention. So thank you, Andrés, Ovais, for joining us this afternoon for the launch of this. And I know, Andrés, you would have liked to join us yesterday, but you were organizing yourself a meeting with the scientific community, and particularly your own scientific community. So I'm very glad you can be here today. Before we go into the substance, and I'll explain how else we will organize things, I suggest we have a very brief video to kick off our discussion this afternoon. So if we could show that, please.
This is our ocean and our cryosphere, the frozen parts of the world. They shape our identities, our way of life. They sustain us and determine our future. But we are changing our planet in profound ways. Human-induced climate change is affecting the ocean and cryosphere and the way they support our lives, impacting our land use, industry, energy systems, urban areas, and infrastructure. In mountain regions, melting of glaciers and thaw are increasing hazards and threatening safe water supplies. Extreme events in coastal regions are becoming more severe. Melting glaciers and ice sheets are causing sea levels to rise. As our ocean absorbs heat and carbon dioxide from the atmosphere, sea temperatures are rising and water chemistry is changing, threatening the marine life we depend on. The IPCC Special Report on the Ocean and Cryosphere in a Changing Climate presents the latest knowledge and opportunities to address the challenges we face today and in the future. We are starting to adapt to unavoidable changes. Reducing greenhouse gas emissions further protects our livelihoods. Together, we can build a sustainable and equitable future for all. Our future is in our hands.
So there we are. And there's a picture of the report, which is now available in its published format. I think a few days ago, was it? You finally got that out. So there it is, and we're going to talk about the report and its content during the course of this afternoon. And I particularly want to welcome the co-chairs of Groups 1 and 2 of the IPCC, Valérie Masson-Delmotte and Padma Ojai, co-chairs of Group 1, and Hans Otto Pörtner and Deborah Roberts, the co-chairs of IPC Working Group 2. And they will be presenting the report during the course of our event this afternoon. So on behalf of SBSTA, let me convey my gratitude once again to the IPCC for their continued dedication and service as a trusted provider and assessor of the best available science And this year they provided us with not just one, but two special reports. And of course, they're also now well underway in preparing the sixth assessment review as well. So the workload of the IPCC is extraordinary. I know how difficult it is to manage. And this special report we're going to look at this afternoon is the first on the specific impacts of climate change on the ocean and cryosphere. It tells us that the world's ocean and cryosphere have been taking the heat from climate change for decades. So we would like this event to help participants, parties, observers, everybody in this room, including members of the scientific community, many of whom may have fed into this as well, and I thank them for that. We'd like to use this to help us all understand the key scientific findings of the special report on ocean and cryosphere in a changing climate. And I hope that our discussion here can also assist the IPCC and the scientific community in identifying areas of interest that could be developed further by researchers and contribute to future assessments. So let me describe briefly how Ho-Sung and I plan to use these 3 hours. In advance of today's special event, focusing on the special report on ocean and cryosphere, we made available an information note to provide background and to propose an agenda. And I hope you have found that. It is on the web page for this event. Finding things on the web is not always easy, but there is a place for cooperation with the science and cooperation with the IPCC, and you have a lot of these, and you will find a dedicated page for today's event. So the co-chairs who oversaw the development of the special report will guide us through it, following the structure of the summary for policymakers. To the extent possible, we urge the presenters to seek to answer the questions that we asked in the information note, and I'm certain that they will be happy to answer questions from the floor during the discussion segments. And I think yesterday we managed well in managing an interaction between the presentations and the floor. So we'll start with a presentation from Permafrost, co-chair of Working Group 1, on the latest science concerning hazards from changes in high mountains and permafrost. And then the other Working Group 1 co-chair, Valérie Masson-Delmotte, will continue by speaking about the hazards from changes in the cryosphere, the ocean, and from sea level rise. And at that point, we will have a first round of questions on those two presentations and associated topics. Following that, we will hear from Hans Otto Pottner, co-chair of Working Group 2, on how to move from risk assessment to adaptation and how to move from risk assessment to adaptation and nature-based solution options, ecosystems and human societies. And the final presentation will be from Deborah Roberts, the other co-chair of Working Group 2, taking us from response options to governance and policies. We'll then have a second discussion session, and I encourage the floor to interventions from the floor. Please keep your questions succinct and take this opportunity to engage the experts fully with your questions. And I hope this will be an interactive learning session, both for parties to hear the latest science and, as I said, to gather feedback on the special report and areas for future emphasis, which will be valuable for the scientific community. And we will reserve some time at the end to sum up very briefly. I'd also like to thank in advance the authors of the IPCC work who are taking part and in our work this afternoon, and some of the experts involved in the special report on climate change inland yesterday. Similarly, experts involved in the report on ocean and cryosphere have also agreed to sit on the panel and take some questions. So thank you to those experts for being willing to engage this afternoon in this exercise. Before I give the floor to our guests, I must ask you to accept my apologies, since I plan to be with you for the whole of the afternoon to co-chair this event with Ho-Sung. Unfortunately, I will have to leave after about an hour to take part in a number of other meetings which have come up in relation to my responsibilities as chair of SBSTA. It is not my desire to do so. I want to spend all afternoon with you, but I do look forward to hearing that you had a very successful discussion. My rapporteur, Stella Gama from Malawi, will take over from me during my absence. So with that, I'd like to welcome Andrés Couve, the Chilean Minister of Science, representing the COP presidency, but who is also making, I know, a major effort to link the action on science very much around climate change and delivering with your own national science community. And I congratulate you for all the work you've been putting in over the last year to make that happen. So Andrés, over to you.
Thank you very much. Good afternoon, everyone. Dear Paul, dear Ovais, Ho-Sung Lee, good afternoon. Dear members of delegations, co-chairs, observers, and NGO members. Dear friends of science, technology, innovation, and the oceans. As the Minister of Science, Technology, Knowledge, and Innovation of Chile, I want to start by welcoming the IPCC report on oceans and the cryosphere. I was fortunate to participate in the opening ceremony in Monaco earlier this year, and I'm very happy to be here to demonstrate our commitment to science, oceans, and the cryosphere. Upon reading the report, one realizes that the observed changes are worrying. Furthermore, the projected changes are even more worrying. Should this paralyze us? Should we promote an apocalyptic vision of the future of the oceans and the cryosphere? Our strong belief is that it is not the time for apocalyptic visions. In contrast, we promote the vision of opportunities that will come mostly from science, from technology and innovation, from the hand-in-hand work of scientists and policymakers. Indeed, the IPCC reminds us that governments may better achieve their social, economic, and environmental goals by promoting science and a broad range of technologies through mission-driven innovation policies. In this context, it is appropriate to ask if we have been true, especially as the minister of the country that presides the COP, if we have been true to our time for action call. Let me briefly go through a few things which I think demonstrates that we have been true to the action call. A few days ago, we launched a platform for ocean-based solutions. We also invited the Chilean oceanographic community, who provided a report and recommendations, the summary of which was presented yesterday here at COP25 in Madrid, and that involved the work of many, many scientists from Chile during the entire year. The recommendations include the creation of an integrated monitoring system, which we are helping to develop at the Chilean Ministry of Science. The monitoring system is also consistent with one of the enabling factors from the IPCC report. We have also been very strong in promoting science at the center of COP25. Indeed, yesterday, we organized the first meeting of science ministers that occurs at a COP meeting. This was a virtual meeting of ministers from all around the world. We gathered 18 countries in a virtual meeting with a low carbon footprint and using the best available technology with a technological partner. The Chilean NDC, which will be delivered in March 2020, includes the suggestions and recommendations of the Chilean scientific community and includes the ocean as an integration pillar of mitigation and adaptation. Furthermore, the long-term planning with Monaco, with the UK, and with many other friends and countries aim to include the oceans as a central aspect of discussions and of actions. The ocean is at the very heart of my country's identity. These that I just mentioned are just examples coming from a recent experience. We look forward to build upon them and to inspire others to be consistent with the Time for Action call, and most importantly, to be inspired by others. There can be no doubt Science must be at the center of the climate action discussion, efforts, and action. I welcome the special report, and I encourage you to continue your work in the same constructive spirit. Thank you very much.
Many thanks, and I want to welcome the way in which the Chilean government has been working to bring the scientific community together with the preparation, involve the scientific community in the preparation of your COP, and in particular around this theme of the ocean, the Blue COP, and the way in which that has been seen by you, pushed by you very strongly as a priority, and thank you for that. With that, I'd hand over to Ovais Samad, Deputy Executive Secretary of the UNFCCC, to say a few words as well.
Thank you very much, Paul. Substitute Chair, Minister Couve from Chile, IPCC Chair, the co-chairs from the IPCC, distinguished delegates, ladies and gentlemen, colleagues, friends. It's a great pleasure for me to be here to represent the UN Climate Change Secretariat on behalf of the Executive Secretary and all of us in the Secretariat at this very important and a very meaningful event. I would like to especially thank the Chair of the SBSTA, Paul, you, and IPCC for your efforts in organizing this event. It is really, as I said, very meaningful and comes at a very timely moment. Without the continued work of the IPCC, we would lack a vital source of the scientific basis on which we build the foundations of all our efforts here at COP throughout the year and in the process. In this particular instance, oceans, as we know, are part of the climate system, and protection of oceans is identified under the Convention, the Cancun Agreement, and also in the Paris Agreement. Healthy oceans are instrumental in regulating the climate system as a carbon sink and are integral to achieving the goals of Paris Agreement and the Sustainable Development Goals. Let me share a few facts which you know better than I. I'm not a person from a scientific background, but still I appreciate very much the scientific evidence that is in front of us. All people on Earth depend directly or indirectly on the ocean. Every second breath we take comes from the ocean. The ocean is also the foundation for vibrant economies. Goods and services from the ocean or crisscross the ocean generate about $2.5 trillion a year, an amount expected to double by 2050. This makes, if ocean were to be considered as an economy, the 7th largest economy in the world. But the ocean is being significantly impacted by the increasing greenhouse gas emissions. The ocean has absorbed 90% of the heat energy generated from global warming, causing increasing ocean warming, ice melt, related impacts including reduced sea ice, sea level rise, deoxygenation, deterioration of marine and coastal systems. Oceans have absorbed 25% of all anthropogenic carbon emissions, causing increasing ocean acidification. So all of that means protection of ocean contributes to urgent reduction of carbon emission concentrations in the atmosphere and adaptation and building resilience to the climate impacts that are already being felt as well as future risk. At this point, let me also share a non-scientific but more personal experience and recently seeing in the television about what's happening to the whales. And recently a whale was discovered at the coast of UK, and it was quite a moving scene. But to give you a vivid example, for instance, whales play a role in regulating our climate system through circulating nutrients in our oceans. By diving to the deep depths and resurfacing, they allow for nutrients from the depths to be brought up to the surface, which increases the algae growth and absorption of carbon from the atmosphere, as well as carbon locked in the plants and krill at the surface to be moved down to the depths of the oceans to be locked away. This example, in a way, illustrates the importance of delicate interconnections between species and the need to protect entire ecosystems to support a healthy climate. COP25 is being held at a crucial time for the oceans, where more and more global attention is turning to the service that our oceans provide. With the parties working on the revised NDCs for 2020, this event and the special report, the launching of this special report with the evidence that it has, provides evidence to help countries to increase their ambition, including action for the ocean. This event will also provide an opportune moment to discuss the findings of the report. And I'm truly grateful that we are webcasting this event so that people outside this room can engage and benefit from the presentations and discussions. In closing, Mr. Chair, I would like to once again express our deep appreciation to the IPCC. We in the Secretariat are committed to working with you on enhancing the flow of information, scientific information, into the UNFCCC process and to provide the best available science to parties to increase their ambition for climate action. Thank you very much.
Thank you very much, Ovais, for that intervention on behalf of the Secretariat of the Climate Convention. As you mentioned, this event is being webcast, so it is possible to follow it live. It also means that it can be followed afterwards. And of course, all the presentations will be uploaded onto the website and the web page, so you can track all of those and all the information which we will get during this afternoon from the authors, the chairs, and in particular in their presentations. All of that will be online. So with that, and once again, with my apologies in advance that I will be leaving you in about half an hour, I would like now to hand over to Ho-Sung Lee, the chair of the IPCC, my co-chair this afternoon, who will provide us with his opening remarks and then introduce the presenters of the first segment and then moderate the ensuing question and answer session. I wish you a very successful and rich exchange this afternoon. Ho-Sung Lee.
Thank you very much, Paul. Your Excellency, Andrei Couvet, Deputy Executive Secretary Ovais Samad, distinguished delegates. I'm very pleased to open the presentation of the IPCC Special Report on the Ocean Cryosphere in a Changing Climate at this SBSTA-IPCC special event. This is the third of our 3 reports the IPCC released this year. Yesterday, we discussed our special report on the climate change and land. And earlier this year, we also released a methodology report, the 2019 refinement. With last year's special report on global warming of 1.5 degrees Celsius, this marks the most intensive and ambitious period in the IPCC's 31-year history. The launch of the IPCC Special Report on the Ocean and Cryosphere in a Changing Climate is the conclusion of 2 years of hard work. This report was written by 104 authors from 36 countries, including authors from 19 developing countries or countries with economies in transition. 31% of the authors are women. Almost 7,000 scientific publications were referenced in the report, which received more than 31,000 expert and government review comments. The commissioning of this report responds to 7 government proposals, including the Principality of Monaco on different aspects of the ocean and polar regions and climate change. In determining the AR6 work program, the IPCC panel took these proposals as well as others on high mountains and decided to prepare a special report on the ocean and cryosphere. This report forms a package with the other 2 IPCC special reports on global warming of 1.5 degrees and climate change and land, looking at the different aspects of the climate system and emissions pathways and response options. And together, With the land report, it complements the IPBES Global Assessment Report on Biodiversity and Ecosystem Services. You can see the chapter structure of this report as following water in all its states, from the glaciers and sources in high mountains to ice sheets in the polar regions to the deep oceans. And it addresses how the sea is rising and how this sea level change in turn impacts coastal and island communities. The summary for policymakers moves from the observed changes and impacts to projected changes and risks and looks at response options. This structure will shape our discussion today, although we will be bringing material up from the chapters. This report is unique because for the first time, the IPCC has produced an in-depth report examining the farthest corners of the Earth, from the highest mountains and remote polar regions to the deepest oceans. We have found that even, and especially in these places, human-caused climate change is evident. This report documents the melting of high mountain glaciers and polar ice sheets, which contain the fresh water for our culture, for our future. It documents the thawing of permafrost, which is the frozen foundation for communities and wildlife habitats of the North. It shines a light on coastal and low-lying areas where sea level rise and associated impacts threaten the lives and livelihoods of large segments of the population. And it documents the ways in which, for decades, the ocean has been acting like a sponge, absorbing carbon dioxide and heat to regulate the global temperature, but it can't keep up. Taken together, these changes show that the world's ocean and cryosphere have been taking the heat for climate change for decades. The consequences for nature and humanity are sweeping and severe. This report highlights the urgency of timely, ambitious, coordinated, enduring action. What's at stake is the health of ecosystems, wildlife, and importantly, the world we leave our children. The front and back cover of this report pays tribute to the various regions addressed in this assessment, from the poles to the tropics. The ocean and cryosphere, the frozen part of the planet, might feel remote to some people, but they impact all of us for weather and climate, food and water, for energy, trade or transport, for health and well-being, for culture and identity. The ocean and the cryosphere are critical for all life on Earth. And this report has shown that if greenhouse gas emissions continue to increase, global warming will drastically alter the ocean and cryosphere. However, if we reduce emissions sharply, consequences for people and their livelihoods will still be challenging, but they will be potentially more manageable for those who are more vulnerable. The report reveals the benefits of ambitious and effective adaptation for sustainable development. Conversely, there may be escalating costs and risks associated with delayed action. We will now move to the substance of today's event, unpacking the new scientific knowledge and key findings. I would like to hand over to Pam Maojai and Valero Masson-Delmotte, co-chairs of IPCC Working Group 1, who will take you through the hazards from change in high mountains and permafrost, and hazards from changes in the cryosphere and oceans, and from sea level rise, respectively. Pan Mao.
Thanks, Chair Hui-Sen Lee. Good afternoon, everybody. Before starting our presentation, I would like to provide some background information to you at first. In our presentation today, we mainly use two emission scenarios, RCP 2.6 and RCP 8.5, but the underlying report covers more in the assessment, reflecting the available literature. RCP 2.6 represents a low greenhouse gas emission scenario, high mitigation future that in CMIP 5 simulations gave us a 2 in 3 chances of limiting global warming to below 2 degrees Celsius by 2100. By contrast, RCP 8.5 is a high GHG scenario. In the absence of policies to combat climate change, leading to continued and sustained growth in atmospheric greenhouse gases concentration. Now I would like start from the mountain Cryosphere. Mountain glaciers, snow and ice, and the thawing permafrost are very visible symbols of climate change. A total of 670 million people in high mountain regions and many hundreds of millions more downstream that are dependent on water from mountain cryosphere. They are increasingly exposed to hazard and changes in water availability due to changes in mountain cryosphere. Ice mass loss of glaciers in all mountain regions is about 123 gigaton per year in 206 to 215. In nearly all high mountain regions, the depth, extent, and duration of snow cover have declined over recent decades, particularly at the lower elevation area. Permafrost temperature average across polar and high mountain regions have increased to record high level from 1980s to present. We have seen changes in hazards and impacts on water availability, floods, landslide, avalanches, and ground subsidence in many high mountain regions. Glaciers, snow, and permafrost decline has altered the frequency, magnitude, and the location of most related natural hazards such as landslides, avalanches, floods, ground subsidence, and wildfires. At the same time, exposure of people and infrastructure to natural hazards has increased due to growing population, tourism, socio-economic development. Some disasters have been linked to changes in mountain cryosphere. For example, in the Andes, high mountain Asia, Caucasus, and the European Alps. Also, we have observed many impacts on ecosystems, such as tundra, forest, lakes, rivers, and human systems, such as tourism, agriculture, infrastructure, migration, cultural service, and ecosystem services. The reduction in glaciers, permafrost, and snow cover alters the land and freshwater habitats of mountain vegetation and wildlife. Lower elevation vegetation and wildlife have changed absence, extended upslope, and established in new areas. Cold and snow adapted species has decreased in absence. Glacier retreat and snow cover reduction have contributed to declines in tourism in many regions, and in agriculture yields in some regions include Hindu Kush, Himalaya, and tropical Andes. What's about the future? For the future, glaciers, snow cover, and the permafrost are projected to continue declining in most mountain regions. Regions with mostly smaller glaciers are projected to lose more than 80% of their current ice mass by 2100 under RCP 8.5 scenario. And many glaciers are projected to disappear regardless of the future emission scenarios. Projected decrease in low elevation winter snow depths compared to 1986, 2005 are likely 10 to 40% by 2031 to 2050, regardless of emission scenarios. For 2081 to 2100, the projected decrease is likely 50 to 90% for RCP 8.5. Widespread permafrost thaw is projected for this century and beyond. By 2100, projected near-surface permafrost area should decrease of 24% for RCP 2.6 and 96% for RCP 8.5. Hazards are projected to occur in new locations and different seasons. In many high mountain areas, glacier retreat and permafrost thaw are projected to further decrease the stability of slopes. And the number and the area of glacier lakes will continue to increase. Floods due to glacier lake outburst or rain on snow, landslides, and the snow avalanches are projected to occur in new locations and different seasons. Future cryosphere change are projected to further affect the water resources. River runoff in snow-dominated or glacier-fed high mountain basins is projected to change with increases in winter runoff and early spring peaks. Runoff from glaciers are projected to reach peak at or before the end of the 21st century, followed by a decline in glacier runoff. Projected declines in glacier runoff by 2100 and the RCP 8.5 scenario can reduce basin runoff by 10% or more in at least 1 month or of the melt season in several large river basins, especially in high mountain Asia during dry seasons. Projected risks for the high mountain ecosystems. The permafrost thaw and the decrease in snow will affect mountain hydrology and wildfire, with impacts on vegetation and wildlife. Future cryosphere change will continue to alter terrestrial and freshwater ecosystem in high mountain, with major shifts in species disturbance resulting in changes ecosystem structure and functioning, and eventually lose their globally unique biodiversity. Warm adapted plant and animal species will migrate upslope. Cold and snow adapted species will decrease and risk eventually extinction, especially without conservation. They also have a lot of risk for the people. Glacier retreat and permafrost thaw are projected to further decrease the stability of slopes, and the number and the area of glacier lakes will continue to increase, hazards for people through landslides, snow avalanches, or floods will increase. The retreat of the cryosphere will continue to adversely affect recreational activities, tourism, and cultural assets. Disaster risks to human settlements and livelihood options are expected to increase. Changing water availability and quality affect households, agriculture, energy system, and people, both in the region and beyond. Limiting global warming would help people to adjust to changes in water supply and limits risk related to the mountain hazards. Significant risk reduction and adaptation strategies help avoid increased impacts from mountain floods and landslide hazards. Integrated water management and transboundary cooperation provide opportunities to reduce the impacts of climate-related cryosphere changes on water resources. With we move to the high mountains, move from high mountain to polar region. Now I hand over to my fellow co-chair, Valerie.
So welcome in the polar regions, and the polar regions are losing ice, their oceans are changing rapidly, and the consequences of this polar transition extend to the whole planet and are affecting people in multiple ways. Polar regions encompass 20% of the ocean surface, more than 90% of permafrost, the frozen ground area, 70% of the total glacier area, and the Greenland and Antarctic ice sheets. This is a schematic representation of the key features and mechanisms by which the cryosphere and ocean of the polar regions influence climate, ecological and social systems in these regions and across the globe. There are multiple and diverse perspectives with respect to the polar regions: source of resources, a key part of the climate system, a place for preserving marine and terrestrial ecosystems and unique biodiversity, a place for international cooperation, and for many, a homeland. Around 4 million people live in the Arctic, of whom 10% are indigenous. This report has incorporated published indigenous knowledge and local knowledge for assessing climate change impacts and responses. Over the last decades, global warming has led to widespread shrinking of the polar cryosphere, with mass loss from glaciers and ice sheets, reductions in Arctic snow cover, increased permafrost temperature, and reduced Arctic sea ice extent. Let's first focus on observed and projected sea ice changes. Arctic sea ice extent has decreased for all months of the year. September sea ice reductions are around 13% less per decade since 1979. These changes are unprecedented for at least 1,000 years. Arctic sea ice has also thinned and is getting younger. Approximately half of this Arctic sea ice loss is attributable to increased atmospheric heat-trapping gas emissions. Changes in Arctic sea ice have the potential to influence weather at mid-latitudes, but there's low confidence in the detection of this influence for specific weather types. Summer-type Arctic ship-based transportation, including tourism, has increased over the past 2 decades, concurrent with sea ice reductions. This has implications for global trade and economies linked to traditional shipping corridors, and poses risks to Arctic marine ecosystems and coastal communities, such as from invasive species and local pollution. Arctic sea ice loss is projected to continue through mid-century, with differences thereafter, depending on the magnitude of global warming. For global warming of 1.5 degrees Celsius, then the Arctic Ocean would only be ice-free in September, once in 100 years. For just half a degree more, 2 degrees global warming, this would occur 1 year in 10, up to 1 year in 3. and hence we'll cover the implications for marine life in the next presentation. Let me mention briefly the state of knowledge related to Antarctic sea ice before moving to the terrestrial polar cryosphere. The Antarctic sea ice cover exhibits no significant trend over the period of satellite observations. There's currently limited evidence and low agreement concerning causes of the strong recent decrease since 2016, and low confidence in projections for Antarctic sea ice. Let's move now to permafrost. Permafrost temperatures in the Arctic have continued to increase by around 0.4 degrees Celsius in the last decade, reaching record high levels. Widespread permafrost thaw is projected for this century. Even if global warming is limited to well below 2 degrees, around a quarter of the near-surface permafrost area will thaw by the end of the century. For high emissions, around 70% of that surface could be lost. Arctic and boreal permafrost contained around 1,500 billion tons of organic carbon, almost twice the amount in the atmosphere. There's currently medium evidence and low agreement whether northern permafrost regions are currently releasing additional net methane or CO2 due to thaw. In the future, increased plant growth in these regions is projected to replenish soil carbon in part, but it will not match carbon releases over the long term, and it's clear that lower emission scenarios dampen the response of carbon emissions from the permafrost region. Let's now move to snow cover. Arctic dune snow cover extent on land has declined by around 30% per decade since the end 1960s, and it represents a loss of around 2.5 million square kilometers. This is due to warming. Feedbacks from the loss of summer sea ice and spring snow cover on land have contributed to amplified warming in the Arctic, where surface air temperature increased by more than double the global average over the last 2 decades. Arctic autumn and spring snow cover are projected to decrease by 5–10% relative to 1986–2005 in the near term, followed by no further losses under a low-emission pathway, but an additional 15–25% loss by the end of the century, with increasing and high emissions. In the Arctic, permafrost thaw and decrease in snow affect hydrology, wildfire, ecosystems, human activities, and infrastructure. What's already experienced? Lake ice cover has also declined. Runoff into the Arctic Ocean has increased. Increased wildfire and abrupt permafrost thaw, as well as changes in hydrology, have altered ecosystem disturbances. There's been an overall greening of tundra, but browning in some regions, and changes in the abundance and distribution of some animals, including reindeer or salmon. Together, these changes impact access and food availability linked to herding, hunting, fishing, affecting the livelihood, health, and cultural identity of residents, including indigenous peoples. They have adjusted the timing of activities to respond to changes in seasonality and safety of land, ice, and snow travel conditions. Communities are beginning to address infrastructure failures associated with flooding and thawing permafrost, and some coastal communities have planned for relocation, but limited funding, skills, capacity, and institutional support have challenged this adaptation. What's projected for the future? Even if the overall water cycle intensifies in these regions, projected decrease in the cryosphere might lead to soil drying, with consequences for ecosystem productivity. Fire is projected to increase across most tundra and boreal regions. A loss of globally unique biodiversity is projected in the Arctic, as limited refuge exists for some high Arctic species, outcompeted by more temperate ones. Woody shrubs and trees are projected to expand to cover a quarter to half of today's tundra area by 2050. About 20% of the Arctic land permafrost is vulnerable to abrupt thaw and ground subsidence. Disaster risks to settlements and livelihood options in the Arctic are expected to increase due to future changes in hazards such as unreliable ice and snow conditions and increased exposure of people and infrastructure. Today, the majority of Arctic infrastructure is located in regions where permafrost thaw is projected to intensify by mid-century. Retrofitting, redesigning infrastructure can halve the costs arising from permafrost thaw and related impacts. Let's now move to ice sheets that have global implications for sea level rise. In the last decade, the Greenland ice sheet lost mass at an average rate of around 280 billion tons of ice per year. This represents around 0.8 millimeter per year of global sea level rise due to surface melting. At the same time, the Antarctic ice sheet has lost mass by 155 billion tons per year, around 0.4 millimeter per year of global sea level rise. And this is mostly due to rapid thinning and retreat of outlet glaciers draining the West Antarctic ice sheet. In the last decade, the mass loss from the Antarctic ice sheet has tripled compared to the previous decade. The one from Greenland has doubled over the same period. Acceleration of ice flow and retreat in Antarctica, which has the potential to lead to sea level rise of several meters over several centuries, is observed in several sectors. These changes may be the onset of an irreversible ice sheet instability, but there's uncertainty related to such a detection from limited observations and understanding. So to summarize, the polar regions will be profoundly different in the future compared to today, and this will strongly depend on the level of future global warming. This will challenge adaptation responses regionally as well as worldwide, especially for sea level rise. Small island developing states are home to 65 million people, and 60 and 80 million people live in low-lying coastal zones today. They are exposed to sea level rise and coastal extreme events. Let's first focus on observed sea level rise. Global mean sea level is rising with acceleration in recent decades due to mass loss from the Greenland and Antarctic ice sheets, as well as continued glacier mass loss and ocean thermal expansion. The current rate of sea level rise is 3.6 millimeters per year. It's unprecedented over the last century and about 2.5 times the average rate of the 20th century. The cryosphere contribution is now the dominant source of sea level rise, exceeding the effect of thermal expansion of ocean water. And the dominant cause of global mean sea level rise since the 1970s is our emissions of heat-trapping gases. Sea level rise is not uniform globally. Regional differences within 30% result from land ice loss and variations in ocean warming and circulation. Differences can be greater in areas of rapid vertical land movement, including from local human activities, for instance, extraction of groundwater. Extreme wave heights, which contribute to extreme sea level events, coastal erosion and flooding, have increased in the southern and northern Atlantic Oceans by around a centimeter per year since the 1980s. And sea ice loss in the Arctic has also increased wave length heights. Finally, this report shows from the literature that anthropogenic climate change has increased observed precipitation, winds, and extreme sea level events associated with some tropical cyclones, which has increased intensity of multiple extreme events and associated cascading impacts. There's emerging evidence for an increase in annual global proportion of category 4 or 5 tropical cyclones in recent decades. Let's now move to projected future sea level rise. Sea level is projected to continue to rise at an increasing rate. The global mean sea level rise projected in 2100 under a low emission scenario is around 43 centimeters above the level of 1986 to 2005. For a high emission scenario, the corresponding rise is 0.84 meters, and the likely range goes up to 1.10 meters in 2100. This upper range is higher compared to the AR5 due to a larger projected loss from the Antarctic ice sheet. Again, sea level projections show different regional levels. Processes not driven by climate change, such as subsidence caused by natural processes and human activities, are important for relative sea level changes and need to be considered. A key thing is that the sea level rise range that needs to be considered for planning and implementing coastal responses depends on the risk tolerance of stakeholders. Those with a higher risk tolerance can use the likely range. But stakeholders with a lower risk tolerance, for instance for critical infrastructure, also consider global and local mean sea level rise above the upper end of the likely range, and from methods characterized by lower confidence, such as from expert elicitation. Sea level rise is projected to continue after the end of this century. The main uncertainty is determined by the ice sheets, especially in Antarctica. At the end of the century, the rate of global mean sea level rise is projected to reach around 15 millimeters per year in a high emission scenario and exceed several centimeters per year in the 22nd century. Rates are, of course, lower with low emissions. Model studies indicate, but with low confidence, multi-meter rise in sea level by 2100 for a high emission scenarios, indicating the importance of reduced emissions for limiting sea level rise on the long term. Beyond 2100, a growing contribution from Antarctica has important consequences for the pace of sea level rise in the Northern Hemisphere. Processes controlling the timing of future ice shelf loss and the extent of ice sheet instabilities could increase Antarctica's contribution to sea level rise to values substantially higher than the likely range on century and longer timescales, but with low confidence. Considering the consequences of sea level rise that a collapse of parts of the Antarctic ice sheet entails, this high impact risk merits attention. Let's now move to extreme sea level events. As you see on the slide, the rise in global mean sea level will cause the frequency of extreme sea level events to increase. As a result, events that were historically rare, for instance, once per century with major storm surges, will occur much more frequently. When are they going to occur each year? Many low-lying megacities and small islands are projected to experience historical centennial events at least annually by 2050 under all emission scenarios. The year when the historical centennial event becomes an annual event in the mid-latitudes occurs soonest in the high emission scenarios than with lower emissions. The increasing frequency of high water levels can have severe impacts in many locations, depending on the level of exposure as well as adaptation. This assessment assumes that the variability of sea level remains unchanged. However, projected changes in waves and changes in tides due to changes in weather patterns and sea level rise can locally modulate coastal hazards. And extreme sea level and coastal hazards will be exacerbated by projected increases in the average intensity, magnitude of storm surge, and precipitation rates of tropical cyclones, and the proportion of Category 4 and 5 tropical cyclones. There are greater increases projected under RCP 8.5 than under low emission pathways from around 2050 to 2100. Let's now move from the sea surface into the depths of the ocean. Due to emissions of heat-trapping gases from human activities, the global ocean has warmed and has taken up more than 90% of the excess heat in the climate system, making climate change irreversible. Ocean warming also contributes to sea level rise, as seen before. In the last decade, around half of the total heat accumulation in the global ocean has occurred in the Southern Ocean, which plays a disproportionate and increasing important role. Due to warming, marine heat waves have doubled in frequency since the 1980s and are increasing in intensity. Surface ocean warming is also making the surface ocean less dense relative to deeper parts of the ocean, which inhibits mixing and exchange of heat, carbon, nutrients, and oxygen. You can see that a loss of oxygen has occurred from the surface to 1,000-meter depth. The ocean has also taken up 20 to 30% of total human CO2 emissions since the 1980s, causing further ocean acidification. The decline in surface ocean pH has already emerged for more than 95% of the ocean area compared to background variability. Over the 21st century, the ocean is projected to transition to unprecedented conditions, with further increase in temperature, stratification, acidification, and oxygen decline. If global warming is limited to 2 degrees, the ocean will take up 2 to 4 times more heat than between the 1970s and today by the end of the century, and up to 5 to 7 times more for higher emissions. Marine heat waves are projected to further increase in frequency, duration, extent, and intensity, with the largest increases in the Arctic and in tropical oceans. Continued carbon uptake by the ocean is virtually certain to exacerbate ocean acidification. Polar ocean will be increasingly affected by this carbon uptake, causing for high emissions conditions corrosive for calcium carbonate shell-producing organisms. These conditions would be avoided for low-emission scenarios. In a warmer world, extreme El Niño and La Niña events are also projected to increase in frequency in the 21st century and to intensify existing hazards. The Atlantic meridional overturning circulation is projected to weaken. But the scale, rate, and magnitude of ocean changes will be smaller under scenarios with low greenhouse gas emissions, and Hans will cover the implications of these ocean changes for marine life in the next presentation. Thank you for your attention.
Thank you very much, Hanmal and Valerie, for excellent presentations, which clearly indicates that the observed changes and projections in the high mountains, permafrost, cryosphere, ocean sea level rise has been severer than we understood so far, and will continue to worsen if no action will be taken. With that, I would like to open up the discussion and invite questions from the floor on this part of the presentation.
So, could you call up the authors to the table?
I would like to invite authors to the podium to participate in the Q&A.
So, my apologies, I'm going to have to leave.
Thank you. I'd like to invite India.
Thank you, Chair IPCC, and thanks to Chair SBSTA, who just left, maybe because of his preoccupation, but both the chairs, thank you very much for organizing this event, which is very informative, very educative. I would like to raise two questions and one thought, one comment, just thinking aloud. So my first question is that the report was accepted and the SPM was approved in IPCC 51st session, I recall, during September 20 to 23rd, 2019. In the same month, the editors of the journal Nature withdrew a paper cited in the special report. And the paper is in volume 563, pages 105 to 108, 2018. And on the 19th of November, actually the journal Nature had alerted that authors have informed of the errors. And the retraction note on the 25th September by the authors also confirmed this. The paper, Chair, is very prominently figuring in your report. In view of withdrawal, what changes are implied for the conclusions drawn from it in the special report, and why paper which was already under a cloud a year ago was made a part of the report. Chair, the second question, quick question, is drawing the attention through you of the participants on another important matter about why not fair treatment to Himalayas, why step-brotherly treatment to them when so many people are impacted compared to Arctic and Antarctic. And the last and the third point, Chair, is about, we heard in the slides projected by Dr. Valerie that summertime Arctic ship-based transportation has increased due to several fold due to global warming. Now, all of us know that, the region is very rich in hydrocarbons, so on and so forth, many other natural resources. So what as parties we can think of not profiting from a disaster, but using the wealth in those places which will be uncovered due to global warming for addressing the causes of global warming and climate change. Thank you very much for your attention.
Thank you, India. We will collect three interventions together, and then we'll hear from the co-chairs for response. I'd like to invite Georgia to the floor.
Yes, sorry, Chair, it's Germany. Hello.
Sorry, Germany, you have the floor.
Sorry, I pressed the wrong button. Germany, together with the EU, member states, strongly welcomes the IPCC special report on the ocean and cryosphere in a changing climate. We thank all the scientists and others involved for providing this important and authoritative and timely scientific assessment. The report complements the 1.5 report by adding detailed information on oceans and cryosphere. And we appreciate the opportunity to participate in this interesting event, and we are looking forward to considering and understanding the knowledge presented in the report under all relevant agenda items. And here's my question. Permafrost is often mentioned as one of the tipping points in the climate system, since its thawing could lead to massive release of methane, triggering a positive feedback loop and leading to runaway warming. But you have just mentioned in your presentation that there is substantial permafrost thaw, but the uncertainty about the net release of greenhouse gases is low. So could you please elaborate more on this statement? There is permafrost thaw, but not massive greenhouse gas emissions. Thank you very much.
Thank you, Germany. I'd like to invite Bhutan and NGOs. Please wait a few minutes before I recognize. Bhutan, you have the floor.
Thank you, Chair. Bhutan would like to express our sincere thanks to SBSTA for organizing this very useful event and the authors for detailing the special report findings. Hope these findings will go a long way in dealing with the dangers that climate change is posing on us. High mountain Asia is already facing substantial risks from the observed decline in glaciers and snow cover. This also entails an increased exposure to natural hazards. One of the slides detailed the risks for mountainous countries. However, we are already experiencing most of the risks at the present level of warming. Could you please clarify which risks are the most pressing ones in the short term, which mountainous communities in high mountain Asia could address in their planning? Thank you.
Thank you. Thank you very much for those very pertinent questions, questions about the specific literature, the details about the scientific evidence related to that, and also regional aspect, for instance, in Himalaya, and also indigenous knowledge there, and uncertainty related to permafrost aspect, and then the short-term risk assessment in mountain region. And with that, I would like to invite the co-chairs to provide responses.
I would take two questions. First, about the mountain region, especially for the Himalaya region. And the first one for the question regarding today, the India delegate, say Himalaya. This year, in this special report, we are very glad to see have a special dedicated chapter on mountain cryosphere. And I also talked with the authors during the drafting period about, how much information can cover in each mountain region. Actually, the author reflected in mountain cryosphere regions the lack of information. So in the table, you see a lot of gaps there. But fortunately, I noticed in Himalaya region and the European mountain region, we have more information than other regions. I think one issue may be because we want to reflect, the influences, impacts for all the mountain region, not to focus on specific one region. But I think that's one of the reasons. Another one is maybe still lack of understanding and knowledge on this area. So that's my personal view. And I would stress, compared with other mountain regions, we have more information in Himalaya already. But I know in this region, such a large population, so many people living in the area, and that is really a very, very important issue for us in the future. And the second one regarding about what will be the major risk we are going to prepare for the future. So actually, a lot of impacts we already have seen in the mountain region, especially in the Himalaya region. And for my understanding, one is, I think related to the water issue, water resources. Another issue is more linked to the influence of the infrastructure, and also should be prepared for all the hazards, as I mentioned. I think those are all important in the mountain area, especially in the high Asia mountain area. Thank you.
So to complement these answers, I would like to address the point raised by India. So the paper that has been withdrawn from Nature has a name of a first author and a year. And the same first author and year is associated with two publications. The one cited in the report is related to ocean carbon fluxes. It has nothing to do with ocean heat uptake. It's referred to in section 5.2.2.3.1 on ocean carbon fluxes. So the withdrawn paper has zero implication for the findings of this report on ocean heat uptake. For the other questions that were brought up, I want to flag the fact that on high mountains, the report has focused the assessment on cryosphere-driven impacts, but there are also climate change-driven impacts, like for precipitation pattern changes or the direct effect of warming. There's a whole table in Chapter 2 in Supplementary Material 2.8 that lists the publications that were available for the assessment. And there will be an opportunity to revisit the observed impacts in high mountains in the Working Group 2 report on the preparation that has a specific item focusing on high mountain regions. And with respect to the Arctic, there were two questions, one on resources and another one on permafrost. And I would like to invite one of the coordinating lead authors of the chapter to provide answers on these points.
Thank you, Co-Chair, and thank you also to India and Germany for the questions on specifying issues related to the Arctic. First to India's question about shipping. Indeed, shipping in the Arctic is a relatively new phenomenon. At least the increase is concomitant with the loss of sea ice in the area, but it's not only linked to that. So increases in shipping in the recent years and decades and projected increases in shipping have clear beneficiaries, and they have clear negative impacts on other communities. There is indeed a growth in economy over this increased Arctic shipping, but in effect, actually, those routes that are classically used and those stakeholders with interests in that are forecast to lose over the increase in Arctic shipping. Maybe more importantly even, the Arctic is only keeping up in terms of marine shipping governance regulations. It's not keeping up at the moment with increase in improvements in marine shipping governance that relates to the increase of shipping. And so the vulnerability is clearly with the local communities who are dependent on marine resources and often dependent on ice that is at the coast. These are features that are going to be disturbed with increased shipping in the region. So those communities are clearly affected by an increase in shipping, and it depends on the increase and improvements of potential governance of shipping if these risks actually are becoming impacts. So that much on the shipping question. Secondly, on Germany's question on permafrost, indeed, as Valerie has pointed out, there is a huge amount of carbon in Arctic permafrost. About 95% of global permafrost is in the Arctic, and there is an increased forecast of those emissions from permafrost, carbon emissions, linked to permafrost thaw. There is limited confidence in the number exact of projections for certain years over the coming century, but there is certainty in the amount of carbon that is cumulative emitted from permafrost carbon thaw over this period, and that is about 10 to hundreds of gigatons per carbon cumulative over this century. As an illustration, about 11 gigatons carbon were emitted through anthropogenic emissions per year over the last decade. So that is a substantial increase, but we don't know exactly when it will emitted in this period. We also have limited knowledge about how much of that carbon will come out as carbon dioxide versus methane, and the difference in radiative forcing between these two gases is huge. So we cannot really elaborate at this point on how much warming this carbon will contribute. But permafrost carbon is emitted over a critical time period where the Earth is struggling with increases in atmospheric carbon. Thank you.
Thank you very much. All right. Delegates, please press the button if you would like to have floor for intervention. I'd like to recognize BNI, ENB NGOs. You have the floor.
Thank you, Chair. I'm representing Climate Action Network International. We have 1,500 NGOs as member, and we have been working closely with and on the IPCC report over many years and also in the UNFCCC. So you can imagine we as NGOs, we have many issues with the 3 special reports in the cycle, the 1.5C report, the special land use report, and the special report on oceans and ice. But the most outstanding and the most important issue we have, Chair, is that we very, very strongly welcome and congratulate the authors, the IPCC, for those outstanding, fundamentally important reports. Thank you for that one. And we would wish, in this process here, that all governments, in particular those who are wealthy and big polluters, would take your findings, which we highly appreciate and believe are very welcome to the process. Take those findings as a fundamental and firm component in order to enhance the NDCs in the coming year by 2020 to address climate change in a much more serious way, which is necessary to meet all the identified possibilities you have laid down in the 1.5C report to meet those survival target of not exceeding 1.5C by 2100. Thank you, IPCC. Thank you, authors, for that one. This is fundamentally important, and we will do everything to disseminate your findings as appropriate.
Thank you very much for your statement. Burundi, you have the floor.
No, it's France. France would like to deeply thank the IPCC for the extremely useful findings of the special report on the ocean and cryosphere. New projections of sea level rise have been presented in this report. And could you provide detailed information on the role of the instability of marine ice sheets on sea level rise? Thanks.
Thank you, France. Bahamas, am I correct this time?
Yes, you are.
Thank you. Bahamas, you have the floor.
Thank you, Chair. I want to congratulate IPCC and for this special report. A part of IPCC, I'm painfully aware of the work that went into producing this report. Mr. Chair, it was about, I think, during the IPCC fourth assessment report, when, could have been before that, IPCC, we started talking about, because of the increase in temperature, the possibility of the increase in tropical storms, hurricanes. In this report, we have outlined in B2, talking about ocean warming to continue throughout the 21st century. And then in B3, we talk about sea level rise and the possibility of extreme events once per year, possibly, that now happen once per century, possibly happen once per year. Just a few points I want to make just to bring home what is actually being said in this report. With the increase in, when you're talking about the increase in temperature in the ocean, we're now talking about available energy for hurricanes. And we in the Caribbean, well, in the Atlantic Ocean, I can speak to specifically, which is the Northern Atlantic and the Caribbean Sea, we have actually seen the effects of this, and we have seen intense hurricanes occurring over the past few years. For example, the Bahamas, my island, 700 islands, average, well, 80% of its land mass less than 10 meters above sea level. We have seen a major hurricane in 2015. We have seen a major hurricane in 2016. We have seen a major hurricane in 2017. And we have seen a catastrophic hurricane on September 1st through September 3rd in 2019. That hurricane is the worst that we have seen ever, resulting in about 70 deaths. More than 1,000 persons are still missing, believed to have been washed out to sea as a result of storm surge. So what we have seen happening is the increase in the intensity in these storms in the region itself, in areas. 2017 was an historic year for us in the Caribbean, where an area in the Caribbean, some of you may know, is known as the Leeward Islands, never seen a Category 5 hurricane. Saw 2 Category 5 hurricanes within a week. It shows that this is real. These things you're saying used to happen once per year, and it could possibly happen once per year now. By 2020, well, we're 30 years out, and we're already seeing it more than once per year. So with that in mind, and with the continued increase that we expect to see going on in the ocean temperature and also in the sea level rise, and we're already experiencing these catastrophic events in our islands throughout the Caribbean especially. What can we look forward to in the next 30 years? Thank you, Mr. Chair.
Thank you very much. Much of the questions you raised also deals with the presentations that will be given in the next round of presentations. So both this co-chair and next co-chairs can answer your questions. I'd like to recognize Canada at this point. No, could you? All right, okay. Some floating. We have a floating microphone. Oh.
Thank you, Mr. Co-Chair. First, Canada would like to thank everyone that was involved in producing these reports, which, of course, they have a wealth of evidence to inform activities here under the Convention as well as at home in our own countries. My question also had to do with the marine ice sheet instability. In particular, the presentation noted that there was uncertainty about whether irreversible ice sheet retreat was already occurring. I'm wondering if you could elaborate about whether we understand better the temperature range at which ice sheet retreat is irreversible, and in particular, if we know much about the upper bound of that temperature range. Thank you.
Thank you for the question. I'd like to invite co-chairs to provide answers. Co-chairs, you have the floor.
Indeed, this report provides an assessment of the latest knowledge regarding the processes of ice sheet instability, both marine ice sheet instability from the literature, as well as a discussion related to another process called marine ice cliff instability. There's a whole assessment of the level of understanding based on today's limited observations, the representation of processes related to marine ice sheet instability in ice sheet models, knowledge from past climate. So I've reported the current level of understanding. It is not impossible that such a process is already at play. The ability of models to simulate the processes controlling marine ice sheet instability has improved, but significant discrepancies in projections remain. This report confirms the findings of the 1.5 report about the range of levels of global warming associated with potential ice sheet irreversible response. And this will again be revisited based on the latest modeling of ice sheets and ice shelves in the main Working Group 1 report. I also would like to mention that this is also the first time that an IPCC report reflects the state of the literature related to event attribution, especially related to tropical cyclone characteristics, intensity of rainfall, winds, and associated storm surge. There's a whole assessment of the literature in Chapter 6 that flags the current level of understanding of how specific events have had their characteristics altered because the climate has changed and the seas are warmer especially. And finally, several of the interventions flag the fact that a specificity of the time response of the ocean and the cryosphere. They are associated with committed changes in the next decades, and this highlights the importance of adaptation and cooperation for adaptation, a topic that will be addressed in the second part of the presentation.
Thank you, Valerie. Is there any need for further explanation about the details by the co-chair, by the authors? None? Okay, thank you. I'd like to invite St. Kitts and Nevis. You have the floor.
Thank you, Mr. Co-Chair. St. Kitts and Nevis wish to express profound gratitude to the IPCC for providing the special report on oceans and cryosphere. In a changing climate, we have heard the intervention of Bahamas, and this is particularly very important for us as small islands. We very much welcome this report because we see this as a critical input to the negotiations that are currently taking place. My question is relating to long-term sea level rise. Should emissions continue to grow, global sea level rise is projected to exceed rates of several centimeters per year, resulting in multi-meter rise in 2300. Given our limits to adapt to sea level rise related impacts, we would like to seek some clarification as to which warming levels will allow us to avoid such catastrophic events relating to long-term sea level rise. Thank you.
Thank you very much. Nepal, you have the floor.
Latik. Okay, thank you, Chair. Nepal would like to appreciate the IPCC efforts, and we are very much thankful for including High Mountain chapter in the report. And I believe for its continuity in upcoming AR6 report, considering urgency of ongoing climate change impacts on high mountain regions and Himalayas. As IPCC report clearly mentioned that the high mountain regions have data gaps and limited research with knowledge on its various aspects, it needs to enhance the research and observation system in high mountains to monitor the climate and provide reliable weather, climate, and water-related information along with evidence-based researches. Therefore, we would like to know how IPCC could fulfill this urgency of high mountain research gap and scientific observation in future so that it can support for climate change adaptation and resilience building for vulnerable communities in these regions. Thank you.
Thank you very much. I'd like to invite Korea and then the co-chairs for responses. Korea, you have the floor.
Thank you, co-chair. In the first place, we highly appreciate to IPCC team for the tremendous work of providing us with 4 reports during just 1 year, following the adoption of special report on 1.5 degrees Celsius last year in Songdo. This year, 2019 refinement to 2006 guideline to national inventory, and 2 more special reports on land as well as the ocean and the cryosphere were adopted this year. This is indeed the amazing job. Having said that, no one can doubt that this special report on ocean and cryosphere is very important in terms of the blue COP at COP25. I hope that this significance will be widely known and more people will pay attention to the forthcoming 6th assessment report. If you allow me to ask a question, I'd like to say that according to this SPM, Many marine species have undergone shifts from equator to the poles. This might lead to the adverse effect of ecosystem in the ocean, for example, widespread disease in the other part of the ocean. In this regard, I'd like to know whether or not the disease in the equator or subtropics are moving to the poles as marine species move. Thank you so much.
Thank you very much. The questions are about the long-term sea level rise, its implications and risks, and the high mountain, the data needs for high mountains, and the shifts in marine species under these rapidly warming situations. I'd like to invite co-chair for answers.
So I want to take the question from Nepal about capacity building, especially for the mountain region. Say in our report, actually in neighboring conditions, we mentioned the monitoring and forecasting, sharing data, information, knowledge. That's very crucial to adapt to the changes in the mountain regions. From my knowledge, after we finished the special report, WMO have taken immediate action. There is a very big event, the High Mountain Summit, to my understanding. I know many authors participated in this summit. That's including establishing the observation network, forecasting, and also climate services for the mountain, weather, climate, and water services for the region. So actually, I think WMO, IPCC already, provided a better, very good knowledge, identify the gaps and the usefulness of the monitoring system to be established in the high mountain area. So that's my answer.
Thank you.
Let me complement that for the aspect related to long-term sea level rise, and I pick up here the conclusion of the corresponding section in Chapter 4. So there's high confidence in continued expansion of the ocean and loss of ice from both the Greenland and Antarctic ice sheets beyond 2100. A complete loss of the Greenland ice sheet, contributing about 7 meters to sea level over 1,000 years or more, would occur for sustained global warming between 1 degree low confidence and 4 degrees medium confidence above pre-industrial levels. There are deep uncertainties regarding the processes that could trigger a major retreat in Antarctica, and low confidence in the estimates of the contribution of the Antarctic ice sheet after the end of this century. And the estimates in this report, by 2300 for a high emission scenario, 2.3 to 5.4 meters, are considerably higher than presented in the fifth assessment report. It's also quite clear that high emission scenarios over several centuries lead to rates of sea level rise as high as several meters per century on the long term. Low emissions scenarios lead to a limited contribution over multiple century timescales. It's not possible to discriminate between 1.5 and 2 degrees scenarios in terms of long-term sea level change due to limited evidence in the literature. So the conclusion is that the sea level rise on 1,000-year timescales is strongly dependent on the emission scenario. Due to the lack of predictability of tipping points, it flags the importance of emissions mitigation for minimizing the risk to low-lying coastlines and islands, even if no tipping points are passed. Thank you.
Thank you very much.
With respect to the shift in disease, I would like to relate to the authors. Alessandro?
So I'd like to respond to the question about poleward expansion of Vibrio, which was put forward by the delegate from Korea. So there is some discussion of this in the Chapter 5 text, in the Human Health and Environmental Health section 5.2.1.1, where we present some evidence of increased Vibrio abundance in the North Atlantic from the continuous plankton recorder, and some evidence of poleward expansion in general of Vibrio pathogens, which at least in the literature has been attributed to climate change. So this will be in line with the question of the Korean delegate. Thank you.
Thank you very much.
I could add to that maybe. With respect to the occurrence of harmful algal blooms, the ongoing changes in ocean parameters like warming, oxygen loss, and ocean acidification are hypothesized to stimulate the occurrence of harmful algal blooms and associated intoxication events. So that is also exacerbating the challenges to human health.
Thank you very much. I'd like to invite Zimbabwe.
Thank you, Chair. Zimbabwe would like to thank the SBSTA for providing this platform, the IPCC co-chairs and authors for this special report. It is our hope that the findings will inform our adaptation and also highlight some of the areas which need further research or consideration in the other parts of the sixth assessment reports package. Chair, much of our livelihoods in Africa are rainfall related and rain-fed, which is influenced by ocean systems. These livelihoods are issues of life and death. They drive our agriculture, and these are bread and butter issues for us. The changes in the ocean and the cryosphere affect these teleconnections with our rainfall system and our livelihoods. But there is limited but critical research which link the ocean warming to increased tropical cyclone activity, be it intensity, frequency, as well as movement. The issue of tropical cyclones for us in Africa do not only affect coastline countries such as Mozambique, but also affect even inland countries, landlocked countries such as Zimbabwe. Like in this year, we are still recovering from a tropical cyclone which swept almost 1,000 people and caused massive infrastructure damage. But during the same season, we had droughts. Share the issue of droughts and the linkages or the impacts could be further strengthened in future reports, because to us, much of our droughts emanate from increased tropical cyclone activity in the Mozambique Channel, which then draw moisture from the southern Africa. That information and that knowledge or those connections or systems, they are less emphasized in the reports, and it is our hope that maybe, and actually a question is to ask through you, Chair, how does the IPCC treat grey literature or other knowledge which is not peer-reviewed? Because there is quite a lot of knowledge on some of these impacts in Africa, but much of it is not in the published due to other special circumstances which limit a lot of peer-reviewed material to get into peer-reviewed material from Africa. So it is a concern and a question on how maybe in future the IPCC will address the issue of other knowledge and grey literature. Thank you.
Thank you very much. I'd like to invite the IOC/INBAR, and then youth, and then Micronesia, and then we conclude this section of the dialogue. Invite the IOC/INBAR. You have the floor.
Thank you very much, Mr. Chair. I'm speaking on behalf of the Intergovernmental Oceanographic Commission of UNESCO. And we would like to express our deepest appreciation to you and to the authors and all those involved in this report. This special report highlights in particular the tight relationship between the oceans and climates. It covers the whole value chain, ranging from observations to science, all the way to policy, assisting in bridging the gap between science and policy. It provides information for developing science-based ocean solutions and help reduce impacts on oceans, its ecosystems, and our subsistence and well-being. We trust that the coming decade of ocean science for sustainable development will be able to continue contributing and make transformative contributions and provide solutions to the problems and the situations you're presenting us. It's time for action, and this is a very important baseline. Thank you very much, Mr. Chair.
Thank you much for your statement. I'd like to invite youth.
Qiyanak. Actually, I am an Indigenous Peoples Organization representative. My name is Daly Samboduro. I'm the International Chair of the Inuit Circumpolar Council. And first, allow me to warmly welcome the report of the IPCC on a matter that is dear to Inuit. Many in the room may not know that the Inuit are the indigenous peoples that inhabit the Arctic regions of Chukotka in the Russian Far East, Alaska, Canada, and Greenland. We are dependent upon both the ocean and the ice. So this report is quite significant to us. I want to underscore and again welcome the sections of the report that are entitled Observed Impacts on People and Ecosystem Services. It is in fact true that we have experienced negative impacts on food security, water resources, water quality, livelihoods, health and well-being, infrastructure, transportation, tourism and recreation, as well as culture of human societies. Significantly, our people, Inuit, throughout Inuit Nunaat, our homelands, have been impacted acutely by climate change. In regard to the report and its emphasis upon Indigenous knowledge, I want to indicate that we ourselves as the Inuit have extraordinary knowledge that we can offer to all of humanity with regard to adaptation and mitigation. I want to also emphasize that the references in the strengthening response options, especially where the report underscores Indigenous knowledge and the value of Indigenous knowledge, that here again we have much to contribute. However, we see this as an opportunity for us to make a contribution through the co-production of knowledge. And so one of my questions to the authors of the report is, how do the authors see the weaving of Indigenous knowledge, the knowledge of our people out there and on the ice as a maritime people dependent upon the marine environment, and Western science and the work that you've produced in this particular report? On this note, I'll conclude with the fact that we believe we have much to offer in terms of our understanding of our knowledge and the important protocols and principles for the co-production of knowledge. So again, Qiyanak to the authors for this report, as well as, I should say, the 1.5 report, which made reference to Indigenous peoples as well. Again, thank you.
Thank you very much. Micronesia, you have the floor.
Thank you. Thank you very much, Chair, and thanks to the working group co-chairs, as well as the IPCC scientists for coming up with this very important report. It basically lent credence to many of the ideas or things that the small island countries have been saying, that we are basically sinking. The cause of climate change and sea level rise as very big effects on our survival. But my question is, since I did not hear, was there any consideration by the group on the effects of, or at least considering the loss of territory and what would actually happen to the islands or countries that has maritime zones, if that will be also affected? Because as the sea level will rise, you will, or a lot of us are going to lose part of our territory, if not sinking. Thank you.
Thank you very much for the questions. Correct question on the use of gray literature and the improved use of the indigenous knowledge, and then the impacts on small island countries and the due to consequences of the sea level rise. I'd like to invite co-chairs and lead authors on this.
Thank you, Chair. With respect to the question concerning grey literature, this is certainly to be included in IPCC assessment reports. We have an emphasis on peer-reviewed literature, but if for any region there is well-documented grey literature available, we would certainly like to see that considered by the authors, and that is regularly done. With respect to maybe the depth of information for the regions, if there is a limited treatment in these special reports, I would like to relate to the regional chapters that will be in the Working Group 2 main assessment reports, and especially for Africa, we have a rich set of African authors to consider that set of information there. With respect to the question of Micronesia, I would like to refer you to the next discussion section, because we will be discussing the risk of sea level rise in more depth in the next section. And with respect to indigenous peoples and Inuits and the use of indigenous knowledge, I would like to relate back to one of the CLAs of the respective chapters.
Thank you very much. CLA. You have the floor.
Thank you for giving me the floor again, and thank you also to Inuit Circumpolar Council for this very relevant question, which is true for the polar regions and actually also acknowledged in the polar regions section of the report, but it is actually also true for other parts of the report, particularly coastal regions and high mountain regions. And as you were asking for specific activities, I refer to also the Summary for Policymakers section C44, where we can see that specific activities include the utilization of multiple knowledge systems and regional climate information into decision-making, the engagement of local communities, indigenous peoples, and relevant stakeholders in adaptive governance arrangements and planning frameworks. We also have found and assessed that the promotion of climate literacy and learning about locality-specific risks and response potential contributes to a better effective adaptation and increased sustainability of natural renewable resources. Such investments can develop and in many cases transform existing institutions, and it is in several cases actually dependent on such transformational change of institutions to enable informed, interactive and adaptive governance arrangements. So these are some concrete findings of the report that span some of the chapters, but are particularly true for also the Arctic. Thank you very much.
Thank you very much. This concludes the presentations and the questions and answers about the first section about of these presentations, that is the hazards from the changes in the high mountains and the permafrost, and also changes in the cryosphere and oceans and from sea level rise. I would like to give thanks for the questions, and thank you, Pamela and Valerie and lead authors, for taking us through this section. I'll now hand back to Stella to continue. Stella, you have.
Thank you very much, Hosang. As he has highlighted. My name is Stella Gama from Malawi. I'm the SBSTA rapporteur, and I'm now sitting in for the SBSTA chair. We will now move from the segment where we were talking about the hazards posed to the ocean and the cryosphere by climate change to the options that we have to respond to these hazards. And then beyond that, we also look at the governance and policies involved in line with our guiding questions, which were provided in paragraph 21 in the information note, which look at the challenges for implementing the responses, the response options to be strengthened, and also the role of local communities and the indigenous peoples, and also the enabling conditions for implementing the responses. Mr. Hans Otto Potner will take us from risk assessment to adaptation and nature-based solution options, ecosystems and human societies. And after that, we will have Mr. Deborah Roberts, who will speak on how we can progress from response options to governance and policies. I give the floor to Mr. Potner. You have the floor.
Thank you very much, Chair. And we've heard about the challenges and the hazards developing in the oceans at global scales by my fellow co-chair, Valerie. And I would like to see the presentation being opened again. And we will continue considering those hazards with respect to their impacts on oceans and marine life, which is already being affected. And the key climate drivers to be considered in the oceans are ocean warming, oxygen loss, and ocean acidification, which act individually but also act in combinations. And certainly also this has consequences for the people that depend on the natural resources coming from the ocean. If we look at the hazards again, and we have seen the global development, we can see that actually these signals are becoming and developing already strongly in different marine regions, ranging from the Arctic, the upwelling systems, to the North Atlantic, the South Atlantic, South Pacific, Southern Ocean, temperate Indian Ocean, tropical Atlantic, tropical Indian Ocean, and tropical Pacific. And the strongest signal visible in all of these systems is the signal of ocean acidification indicated by the level of confidence. Temperature is also rising more or less in most of these systems, and we also see a trend towards a decline in oxygen content. In the Arctic, we have a loss in sea ice coverage, and in all of these systems, we see an increase in sea level. And this has consequences which you see indicated for the different systems that are in question here. We are first looking at the ecosystems from the upper water column to coral, to coastal wetlands, kelp forests, rocky shores, deep sea, polar benthos, and sea ice associated ecosystems. And you see for some systems, they are currently responding positively, partly due to the stimulation of productivity, but for most of them with different levels of confidence. The red color indicated here indicates, shown here, it indicates negative consequences. The human systems, depending on those ecosystem services, are in actual fact also responding relatively strongly. We see a development again of the reddish color for fisheries, tourism, habitat services, transportation, shipping, cultural services, coastal carbon sequestration, which are mostly responding negatively to those challenges. So this is in covering the observations. And we are now moving to the projections. How will these changes develop in the future? And I will talk about this from the point of view of risk assessment, distinguishing different levels of risk from undetectable, which is represented by a white color, where impacts and risks are undetectable, to yellow, moderate risks, where impacts risks are detectable and attributable to climate change with at least medium confidence, then going to high risk, depicted by the red color, and indicating significant and widespread impacts and risks, and then going to the purple color, very high risks, where the purple indicates very high probability of severe impacts and risks, and the presence of significant irreversibility or the persistence of climate-related hazards combined with limited ability to adapt due to the nature of the hazard or impacts risks. And we will walk you through the different ecosystems, and we'll start with one of, or the most vulnerable ecosystem, the warm water coral reefs, where marine heat waves have already resulted in large-scale coral bleaching events, causing worldwide reef degradation. And this, the reports on the vulnerability of this ecosystem started in the AR5, and with probably also in the AR4, and was emphasized in the special report on 1.5 and in the ocean and cryosphere report. The risk assessment indicates that under current degrees of warming, indicated by the grayish bar on the left-hand side, we are already in a high-risk situation, reflecting that the healthy reef indicated in the photo on the left-hand side, the corals which are depending on their power plants, which are the unicellular algae living in the coral body. These are being challenged by the high temperature, and the effect is a release of those algae, the loss of the energy producers for those animals, and they start starving. We see that as large-scale bleaching events, and if this heat wave is lasting too long, these animals are no longer able to recover, they die, and the system turns into something completely different, overgrown by algae, as you see on the right-hand side. So these processes are already in place. We have passed the tipping point for those systems. With a very high confidence, we can make this statement. And as we move to global warming of 1.5 degrees, even in such a mellow warming degree that we might consider to be a mellow warming, there is a high risk of losing 70 to 90% of coral reefs and associated services for humankind, and even more will be lost at 2 degrees. Let's move to the other ecosystems and as they respond to warming, and you see the risk level for the warm water coral depicted on the left-hand side, and you see the good news is that for many of the others the risk transitions are not occurring at similarly low temperatures. If we compare here again and put the Paris Agreement temperatures and temperature range onto this slide, we can see if countries are able to accomplish and reach and keep global warming to within this temperature range, none of these systems will actually go into a high-risk situation. So the good news is that these ecosystems would benefit from ambitious mitigation. Nonetheless, in all of these systems, projected ecosystem responses include the losses of species habitat and diversity and degradation of ecosystems functions. In all parts of the ocean, we see the related impacts of climate change. Warm water corals are at high risk already today. Most coastal ecosystems are also responding, including seagrass meadows and kelp forests. They are at moderate to high risk at 1.5 degrees, and risk increases at 2 degrees. Ecosystems overall would benefit from keeping warming at or below 1.5 degrees. Now let's move into the open oceans and look again at the large-scale global changes that are being projected for the ocean ecosystems. And the physical and biogeochemical changes in the ocean affect primary production, for example, and the base which is the base of the oceanic food web. They also affect marine animals through those food webs, but also directly. Animals are actually among the most vulnerable organisms in the ocean that are responding to climate change. And they are in that way directly and indirectly affected by the abiotic and biotic changes in the ocean. And the panels you see there, we will be looking at them individually after this, range from a depiction of net primary production to the total animal biomass, and then to the shifts in maximum fisheries potential, which build on these changes. Now, if we look at the future changes in primary production here, you see that the models are not fully able to depict the current trends. There's quite some disagreement among them, especially for the high emissions reduction scenario RCP 2.6, but the signal emerging for the RCP 8.5 scenario is stronger and indicating an increase in productivity in the high latitudes, especially in the Arctic, whereas in the lower latitudes there is a decline, especially in the area of the tropical gyres. So some desertification here would be going on and is projected to be going on in the oceans in terms of a decline in productivity. We can summarize that for ocean warming and changes in net primary production, that warming alters the biomass production and structure of marine ecosystems. In recent decades, Arctic net primary production has increased in ice-free waters and is projected to further increase. There are cascading effects based on this process on polar zooplankton that has affected food web structure and function and fisheries. In the Antarctic, the habitat of Antarctic krill, a key prey species for penguins, seals, and whales, is projected to contract southwards. And under high emission scenarios, net primary production in tropical oceans will decline by 7 to 16% by 2100. If we look at the changes in animal biomass, including fish and invertebrates, these changes in productivity have implications for those changes, but as I emphasized earlier, there are also strong direct effects of different climate change parameters on individual animal species. And if we compare these scenarios on this slide, you see that under an ambitious emissions reduction scenario, the current trend of poleward displacement of animal species is going on with an enrichment towards the higher latitudes and some replenishment of biomass in the lower latitudes and in some other areas where warming and warming velocity actually plays a role. Then on the right-hand side, we see those trends being emphasized. Essentially, there is a challenge that global warming, based on the principal effects of warming on these organisms, causes a clearance of the lower latitudes from biodiversity and from animal species in similar ways as it has occurred during past mass extinction events in Earth's history. And once again, we see a moderate shift. We see some strengthening of animal biomass towards the high latitudes. And saying that, I must emphasize that these models may have their limited value once they go into the really high latitudes, into the polar areas, because they do not fully reflect the different environmental conditions in those places. If we look at the consequences of these processes, there is then pressure coming from the invasion of the polar areas by species coming from the lower latitudes. And the different drivers of ocean change, like acidification, stratification, ocean warming, also range to some extent into the polar areas, as indicated by the reddish squares that are indicated here. There's a loss of habitat range and foraging success observed in polar areas for ice-associated marine mammals and seabirds. And there's also, this is accompanying also the retreat of sea ice cover. This picture has an emphasis on the Arctic, and there is an expansion currently already of subarctic fish communities that is projected to occur further on into the future. Which means for indigenous people and those living in the Arctic, there is a disrupted access to hunting and fishing areas for Arctic residents, including indigenous populations. Now let's move to the implications of these trends for fisheries, for the maximum fisheries catch potential, which certainly builds on the biological changes and responses to climate change in the ocean. And this is emphasized here for the shelf areas, and essentially it mirrors the trends that I've emphasized for animal biomass. Even under ambitious emissions reduction, we will see some loss in fisheries catch potential, especially in the lower latitudes and where it's affecting the small-scale artisanal fisheries activities, especially in developing countries, challenging their food security. In other places, like especially in the high latitudes, we are already seeing an expansion of fisheries activity following the expansion of some subarctic fish species into polar, especially subpolar waters like the Barents Sea. And these trends are projected to be emphasized under an unabated emissions scenario, RCP 8.5, where you see, according to the strengthening of the colors, an even stronger decline in fisheries catch potential in the lower latitudes. If we summarize such changes, building on the future changes in marine species distribution and production, certainly the unifying principle to consider is that there are limited temperature ranges and that the current rate of climate change obviously is too fast for many species to be able to adapt to the ongoing warming trend, which is faster than it has occurred in any of the climatic changes during the last 50, if not 300 million years. Changes in the ocean cause shifts in fish populations and catch potential, and these have positive and negative impacts on catches, economic benefits, livelihoods, and local culture, depending on the region where we are looking. Global warming and biogeochemical changes have already contributed to reduce fisheries catches in many regions. And communities, for example, in the Arctic, small island developing states that depend highly on seafood may in the future face risks to nutritional health and food security. Now, having covered the challenges of climate change in the ocean, I will move again back to the issue of sea level rise. And we will look at the respective risk assessment, looking at representative places, illustrative geographies, where actually we can make differentiated statements on the development of risk depending on different mean sea level changes according to emissions scenario. In this figure, we compare again a high ambition emissions reduction scenario indicated by the bluish color range and the high emissions scenario, RCP 8.5, indicated by the reddish color change. And then for each of those places, you see two risk columns following the same color scale as in the earlier burning embers. And the left column indicates low to moderate adaptation at current scale, whereas on the right-hand side, we have extrapolated, and the adaptation efforts have been extrapolated to a high level, and considering how the development of risk would actually respond to these adaptation efforts. And what this figure compares are resource-rich coastal cities, large tropical agricultural deltas, Arctic communities, for example, along coastlines, and for example on the islands in the Arctic, and then urban atoll islands in the tropics. And what you see that the risk development and trajectory certainly is most strongly developing for the atoll islands, and to some extent also for the Arctic communities. The risk challenges are somewhat less for the large tropical agricultural deltas, depending on the degree of sea level rise. And resource-rich coastal cities will be able to mobilize the resources to be able to cover the challenges of sea level rise towards and respond appropriately towards the end of the century. The adaptation capacity is reflected here, and the response capacities and adaptation limits certainly differ between locations and regions. And you see the dark green color reflecting the adaptation capacity in situ. That means citizens do not have to respond by movement, whereas the light greenish rectangles indicate when planned relocation is needed in order to respond to the challenges imposed by sea level rise, and when limits are reached with respect to alternative responses. And planned relocation may have to occur especially strongly, and to some extent in some places is already occurring, at least locally, in the Arctic communities and in urban atoll islands, because adaptation efforts are not sufficient to reduce the risk level, sufficiently reduce the risk level in situ. Now, various adaptation responses to sea level rise are actually and already being implemented worldwide, including hard protection, sediment-based protection, ecosystem-based adaptation based on corals and wetlands, coastal advance, coastal accommodation, and retreat. And certainly one of these systems, like the use of the services by warm water corals, is already under pressure, and people will not be able to explore that further if global warming goes on unabated. Indicating that, again, in the developing countries, people with the highest exposure and vulnerability are often those with the lowest capacity to respond. For each of those adaptation measures, the report has assessed their effectiveness, the advantages of their uses, co-benefits, drawbacks, economic efficiency, and governance challenges. And if we look at hard protection, this is especially something that is most useful for the resource-rich cities, coastal cities, and it can actually respond to multiple meters of sea level rise and effectively reduce risk levels. So it will reach predictable levels of safety, and depending on the system used, there may be multifunctional dikes which will also strengthen recreational activities or under other land uses. On the downside, there is a destruction of natural habitat and ecosystems. Economic efficiency can be high if the value of assets behind protection is high. But unfortunately, the governance challenges include that the measures are often unaffordable for poorer areas. Comparing this to coastal advance, which is another measure that can be used in resource-rich places, would also be effective against multiple meters of sea level rise, reach predictable levels of safety, and it would actually have the co-benefit of generating land and land sale revenues. The drawbacks include groundwater salinization and enhanced erosion and loss of coastal ecosystems and habitat again. The economic efficiency is very high if land prices are high, but again, challenges are these measures are often unaffordable for poorer areas. Moving us to the next one, the ecosystem-based adaptation, which include coral and wetland conservation or restoration measures. These are actually dynamic measures which are effective and may be able to respond and cover up to 0.5 to 1 centimeters per year of sea level rise. There is an opportunity for community involvement. The co-benefit would include habitat gain and biodiversity gain. The drawbacks include the vulnerability of corals to climate change. Really, the effectiveness then depends on ocean warming, acidification, and emission scenarios. For wetlands, the safety levels are less predictable, and there's a lot of land required. There is a limited evidence on benefit-cost ratios, and there are governance challenges involved because there's a lot of land required. Permits are difficult to obtain. There's a lack of finance and lack of enforcement of conservation policies. Now, there's one aspect I would like to emphasize finally, and the sea level rise is actually able to illustrate that. There is also a time dimension to be considered in risk reduction. And actually benefits of adaptation measures may be time limited. And you see here in a schematic way how the development of risk can be compared across places and across emission scenarios, also considering the adaptation effort. And a combination of adaptation and mitigation efforts would actually lead to a maximum degree of risk reduction. But nonetheless, the amount of risk reduction and delay depends on sea level rise and on the response scenarios, and it varies between contexts and localities. So while some places may be able to reduce risk levels long term, in other places risk levels may still creep up and at some point reach unacceptable levels. So this time dimension is reflected here on a horizontal axis, indicating that the time gained is maximum under combined emission reduction effort, mitigation efforts with maximum adaptation efforts, considering that still risk thresholds may be reached over time in some places. So, considering the benefits of responses to sea level rise and mitigation, risks may continue to increase at different rates, exemplified by sea level rise, also depending on the capacity of responses, for example, local adaptation capacity and/or retreat, as well as depending on mitigation effort. Risk reduction through adaptation may therefore be time limited, and which emphasizes the urgency of sufficient action, not only at the adaptation front, but also at the mitigation front. And with that, I would like to hand over to my fellow co-chair, Deborah, to take us into the realm of governance and policy.
Thank you. Thank you so much, Hans. And I know it's been a long afternoon for you, but I think given the seriousness of the messages my fellow co-chairs have laid before you in terms of projected and observed impacts, you can see the necessary emphasis on action and the need to move into considering how we best respond to these complex systemic challenges that have been laid out. And that draws us back to a point that we discussed yesterday when we reviewed the special report on land, that important triumvirate which facilitates our action, the interaction between governance, policy, and institutions. And the role of those three important tools that we use, governance, policies, and institutions, is to reduce risk to society and the important natural ecosystems on which we're dependent. And I believe the previous presentations highlighted just how dependent we are on these two important and significant global systems. In terms of the work that we do at the IPCC, risk has a certain understanding. It's the product of the interaction between climate hazards and the levels of exposure and vulnerability that we see in the impacted natural and human systems. And so obviously, if we're thinking about policy and governance, the ability to reduce risk, adaptation offers us a possibility of acting on those three components of risks. Certainly in terms of hazards, the ability to reduce those, and Hans has already underscored the importance of ecosystem-based adaptation. For example, the use of mangroves to alleviate coastal storm energy. And we've heard today from delegates on the floor the kind of impacts that are being seen in the coastal environment. There are also opportunities to reduce vulnerability and exposure. For example, regulations requiring hazard-proof housing and infrastructure and smart planning, so risk-sensitive land use planning that reduces the exposure of human communities and their infrastructure to particular risks such as storm surges. But it's important to underscore, and it's a message we saw yesterday in the land report, is that there are limits to what can be done. Adaptation is not a silver bullet. We cannot adapt our way out of the problems that have been outlined in the context of the ocean and cryosphere systems. And those limitations to adaptation can be broad-ranging. They can be physical, simply just not enough space to move. Ecological, they can be technological, they can be economic, a lack of resources. Previous presentations have underscored the fact that poorer communities are going to find it more difficult to adapt. They can be political. The lack of political will is a significant hurdle, as well, we all know. They can be institutional, psychological, social, cultural. There can be a lack of willingness to change behaviors that put human societies at risk. So here we have a challenge. Adaptation offers us an opportunity to respond to the challenges we've heard to date, but there are limits to adaptation. There are other limits. The temporal scales of the climate change impacts that have been described to you and the very significant societal consequences that come from the changes in the ocean and the cryosphere happen on time horizons which are much longer than the governance arrangements we have in place to respond to them. So both Valerie and Hans have spoken extensively to the issue of sea level rise. And Valerie pointed out that we're going to see enduring, unprecedented changes, potentially in sea level rise, over many centuries. That aligns then with planning cycles, decision cycles, allocation of finance, which typically happen over 3 to 5 years. So you have your planning responses happening over 3 to 5 years and have your changes happening over 300. So we can see the disjuncture that creates in responding to these very significant challenges. Other challenges rise from the impacts that are caused by these climate-related changes in both the oceans and cryosphere, which challenge our existing governance efforts to respond to them, to develop these important adaptation responses that enable us to reduce risk. And we have to do that at all scales. We've heard today that the impacts range from the individual all the way through to the global. The problem is the level of the impacts that have been described are large, they're long-term, they're systemic. They impact literally from the top of the mountains to the depth of the oceans. They are extensive. And therefore, it should not surprise us that the report calls out that in some cases, governance systems will be pushed to their limits. And we heard today, I think, very clear examples of that from the floor. The delegate from Bahamas cited a number of examples where governance is simply overwhelmed by the scale of the event. The example that was called out was the large hurricane in the Bahamas of this year. the Leeward Islands impacted by 2 Category 5 hurricanes. We could see under those sets of circumstances the level of impacts that governance systems are overwhelmed or can be overwhelmed. Why are governance systems at risk given the kinds of impacts we're observing and that are projected going forward? Again, we go back to messaging, which was underscored in the land report yesterday. In many cases, the governance arrangements for these important systems, be they land, be they ocean, be they cryosphere, are simply too fragmented across administrative boundaries and sectors to facilitate the integrated responses that are required to these systemic changes, these cascading risks from the climate-related changes in the systems in which we are interested. And so the report really underscores that the governance systems, which provide us with our key tool of response, are not up to the challenge that the changes in these 2 major global systems are posing. I've already underscored the fact that there are other barriers, for example, financial, technological, institutional. These will be of no surprise to the delegates in the room. These are matters that are central to your discussions. These barriers hinder the ability to respond to some of these challenges. We also see, and Hans has already underscored this, that adaptive capacity is not uniform across the world. It differs between communities and societies. And again, we've heard that in terms of the comments that have come from the floor today. Often people with the highest exposure and vulnerability to these existing hazards and projected future hazards from these 2 major Earth systems are often those with the lowest capacity to respond. So how do we begin to respond to these challenges of limits to adaptation, of timelines being unsynced, of fragmented governance systems? Well, one of the important responses that the report and the SPM calls out is the need to reduce other non-climatic stresses on these 2 important systems. And examples are given of pollution and habitat modification, because by addressing these kinds of non-climate impacts, we give the ability to species to adjust to changes in their environment. The report also calls out, and it's underscored in the SPM, and this is a meme you will remember from yesterday's presentation on land, the importance of integrating our policy frameworks in order to increase the opportunities for adaptation in both human societies and in natural societies, ensuring that the policy frameworks where there are similarities between systems and natural synergies and co-benefits such as water management, fisheries, networks of protected areas are aligned and coordinated not only together but across scales so that we're seeing vertical and horizontal integration. Nature-based adaptation is something that's been called out in all 3 of our special reports. It's no surprise that it's called out in this one as well. But this report underscores that this can be effective locally, because we must remember that many of these global changes in these big systems have serious local impacts. We can make those interventions, nature-based interventions, most effective when they're supported by local communities, and that underscores the importance of engaging with local communities. They are science-based, but importantly, again, going back to the discussion we've just had, draw on that all-important local knowledge and indigenous knowledge to inform that action. Such approaches, so approaches that reduce non-climatic stresses, involve the engagement of nature-based solutions, see the capacitation of people, allow us to ensure that these interventions not only address climate-related challenges, but give us multiple benefits across a range of developmentally important issues, such as biodiversity, human development, and importantly, climate mitigation. Other opportunities for improving our effective responses to the challenges posed by the changes in these 2 global systems. Again, this is a message which you will see echoing the messaging from the land report that we presented yesterday, intensifying cooperation and coordination across all scales, jurisdictions, sectors, policy domains, and planning horizons. And that's why things like the COP are so important. They provide us with the global platform for ensuring that cooperation between stakeholders at the global level. Important too in this cooperation is the sharing of data and information that comes from long-term monitoring and forecasting, which are important enablers in responding to the changes and challenges in these systems. Important too, regional and transboundary cooperation, which can be facilitated through the judicious use and coordination of treaties and conventions. Investments in education and capacity building. Again, this is an important message we heard yesterday, including engagements with local people and indigenous peoples. And again, that was called out in the discussion we've just had, is that the role of local stakeholders is critical, but we must look to ensuring investments in education and capacity building that allow them to bring all of their strengths to the table in this important debate. And again, another important message which goes across all of our reports, we can't only act on the climate-related challenges linked to these two systems. All of these actions have to occur within a broader developmental framework linked to our broader aspirations as a global society of sustainable development. And key to tackling the issues of sustainable development are the need, obviously, to address the importance of social vulnerability and equity. So ultimately, what does the Special Report on Oceans and Cryosphere, that we fondly know as SROCC, bring to the table? It reveals the benefits, as do the other special reports, of ambitious mitigation and effective adaptation for sustainable development, because climate is not seen separate from the broader development agenda. And conversely, the escalating costs and risks to us and the natural systems that we are reliant on if we delay action in that regard. So ultimately, what does SROCC tell us? It really underscores the scale of the challenge we face, and in many ways, I think this special report brings to us as human society the biggest challenge we face, because these two big global systems cover 80% of the Earth's surface. They are life-sustaining systems. Not one of us in this room is not impacted by these two systems in some ways in parts of our lives, and they are severely impacted by climate change. We've heard the evidence by my fellow co-chairs of enduring and unprecedented changes in these major global systems. These are changes that will impact on our lives and the lives of generations to come. Importantly, the Special Report on Oceans and Cryosphere brings knowledge to the table that allows us, and indeed I hope allows you during the course of these weeks, to act and to begin to consider the options that are available to us as society to respond to these widespread and enduring changes. Probably the most important message, and we've underscored this in every special report, is the sense of urgency in action. Timely action, near-term action, ambitious action, action that is coordinated between various parties at all scales, from individual to international, in order to deal with these widespread and enduring changes. This report also underscores that important factor of protecting and restoring the ecosystems on which our development depends, and the careful management of these natural resources in order to reduce risks that we experience from the changes in these two systems, and that brings to us multiple societal benefits. It underscores the importance of people, community, and governments in tackling these unprecedented changes, the need to have a variety of stakeholders involved in the unprecedented transitions that are important for society to consider in responding to these significant changes. This call for these unprecedented systemic transitions have been with us since the Special Report on 1.5. You saw them echoed in the Special Report on Land yesterday, and they are reinforced in the Special Report on Oceans and Cryosphere. It also provides us with the evidence of the benefits of combining different forms of knowledge, combining scientific knowledge with important local and indigenous knowledge, and we've already touched on that point in our discussions today. And it focuses for the first time on the importance of education and climate literacy in increasing our capacity to be able to respond to these challenges. Again, another important message that echoes the messages of the Land Report. And so, another high-level message, an important take-home message from the special report on oceans and cryosphere, which we've seen repeated now for the third time in the special report. The more decisively and the earlier we act, the more able we will be to address unavoidable changes, manage risks, improve our lives, and achieve sustainability for ecosystems and people around the world, both today and in the future. And so if you want the byline for the Ocean and Cryosphere report, these two systems sustain us, but they are under pressure. Their changes affect all of their lives. The time for action is now. Thank you very much.
Thank you very much, Mr. Portner and Ms. Deborah, for your presentations. At this point, allow me to invite the IPCC experts back to the panel, the experts for the working group 2, back to the panel, and also open the floor for questions on these two presentations. In the interest of time, may I request delegates to keep their questions very concise to the co-chairs this evening. Thank you very much. The floor is open. I recognize the youth requesting for the floor. You have the floor. Please give mic to the youth.
Thank you, Chair, for taking me. I'm speaking on behalf of Yango, the youth constituency. And I want to tell you that I really appreciate the report from the IPCC. And as you said, with increasing temperatures and landscapes will change, glaciers will fade away and ice cover decreases, if I understood you correctly. Future generations will probably not know how this looked like, just from pictures. Today, we only know about mammoths, for example, from graphics, as we can see on the back sides of your laptops on this scene up there. If I understood you correctly, with a temperature increase of 2 degrees Celsius, corals will disappear at all and will be for sure extinct. And moreover, the generation to come will not know what a polar bear was. They will just know them from movies, probably. Future generations will not know how a normal life looked like. They will have, as their daily business, typhoons, floods, and droughts. And instead of focusing on an enjoyable life, they will struggle for their daily survival. As I can mention, a lot of people have this as their daily life today already. I was always told, humans, men and womankind, they are able to anticipate their actions. They are empathic, and they are able to reflect on their actions. Yet I don't see this anymore, and I don't believe it. We call this blue COP, the COP for action, but I have not seen this yet. To all science skeptics, I urge, you are the biggest uncertainty in all this. We don't need a crystal ball to see the future. Science is telling you directly now what will happen. So I would like to come to my question now. How, dear scientists, can we show the future generation, the few survivors of wars about fruit and fresh water, what a glacier or warm water coral was? How will they know how the beauty of this living species was? How can we tell them? How can we maybe conserve some of them? And how can we tell them of a future that they don't have because their forefathers deprived them of this? Thank you.
Thank you very much, representative for the youth. Fiji, you have the floor.
Fiji would like to join others in thanking the IPCC for delivering this report. It means a lot for small island developing state like Fiji. Now my question is, we have learned that the impacts on ocean ecosystems are already very concerning. The IPCC SROCC assessed the ecosystems with adaptation potential face clear efficiency limits under ongoing climate change already. Mangroves and salt marshes, for example, would only provide ecosystem-based adaptation potential below 1 centimeters of global mean sea level rise per year. Could the authors please clarify which scenario would allow sea level rise rates to be limited to below 1 centimeters by the end of the 21st century? Thank you.
Thank you very much, Fiji. Antigua and Barbuda, you have the floor.
Thank you so much, Madam Chair, and thanks to the IPCC also for this special report. Ambitious adaptation, including transformative governance, is expected to reduce risk. According to the special report of climate change, according to the special report of Oceans and Cryosphere, coastal protection can, for example, reduce flood risk globally by 2 to 3 orders of magnitude during the 21st century, but depends on investments in the order of tens to several hundreds of billions of US dollars per year, and cost being particularly high for small island developing states. Could the IPCC provide insights how these enormous investment sums could be freed for this purpose, keeping in mind that many vulnerable regions face severe financial limitation already today? Thank you.
Thank you very much, Antigua and Barbuda. I have requests for the floor from 7 more parties. So I will close. Finland, Norway, Suriname, Micronesia, South Africa, Sweden, and then we also have FAO. And we'll close the list in the interest of time. Finland, you have the floor.
Thank you, Madam Chair. Finland would also like to thank the scientists involved for providing this important and timely scientific assessment in support of the work of the UNFCCC. Furthermore, we want to express a special appreciation for the efforts of the IPCC to communicate the key findings to the policymakers. The risk assessments and the response measures that were just presented in the last presentation were just excellent. I would still like to ask if you could explain the IPCC's approach to assess uncertainty and how it deals with issues of very high risk, but also high uncertainty. And here I'm maybe thinking more of the policymakers, how they would react and understand these kind of how to react when there is a very high uncertainty, but the risk is very high. Thank you.
Thank you very much, Finland, for that intervention. And may I also request the co-chairs and the experts to take note. We'll finish the round of interventions, and then we will have the co-chairs and the experts provide feedback. Norway, you have the floor.
Thank you, Madam Chair. We also would like to congratulate IPCC with a very solid and relevant report and all the people that have been involved in making the report. I think one of the very important results from the report is that it is a large difference between the impacts on the ocean and the cryosphere, between a low emission pathway in line with the Paris Agreement and high emission pathways, which underlines the need to reduce the emissions in all sectors. At the same time, we also have a lot of carbon stored in coastal blue carbon systems, and they are also facing risks related to warming and marine heat waves. I think the report also describes the solution space, and my question would be to what extent it is possible to restore vegetated coastal ecosystems as a mitigation option, and also what kind of benefits that could be related to such restoration and when it comes to adaptation and other measures. Thank you.
Thank you very much, Norway. Suriname, you have the floor.
Yeah, thank you. Thank you, Madam Chair. Thank you to the IPCC authors and the special report. Starting with this, that Suriname is benefiting from the presence of the mangrove at the coastline under the present conditions and circumstances. In the case of Suriname, the mangrove ecosystems are not a standalone system, but is supported by and associated with the presence of the mudbank. The mudbank is a dynamic system that moves under the pressure of under the current of the ocean, the North Brazilian current and the Guyana current to the west. It should be noted, however, that the sediments are originated from the Amazon basin and are transported over long distance to the coastline. The question is whether the transportation of the sediments and the movement of the mudbank in the future will be affected on the sea level rise and how this particular ecosystem will adapt to these changes. Thank you.
Thank you very much. Next, I have Micronesia.
Yeah.
Thank you, Madam Chair. Before I make my intervention, I'd just like to thank the representative of the youth group for her statement. Micronesia is located in the Western Pacific. Along with the Central Pacific, these two areas, historical observations have shown that we have relatively higher sea surface temperatures and sea level rise increases than the rest of the Pacific. During the first round of presentations, it was noted that there are regional variations in sea level rise. Now, could the presenters provide some views on the implications of this for the future projections? I thank you.
Thank you very much, Micronesia. I now have South Africa. South Africa, you have the floor.
Thank you, Chair. South Africa welcomes the report very much. What I'd like to ask is there not a real need to bridge the gap between the summary report for policymakers, which we've all just received here, which is very dense, and beautifully crafted descriptive text of the main report, so that more people can get a better understanding of what is happening and not just get a stream of facts. Thank you.
Thank you very much. I now give the floor to Sweden.
Thank you, Madam Chair. Sweden, as a country in the northern part of the world, like the EU and many others, strongly welcomes the IPCC special report on the ocean cryosphere in a changing climate. And I would like to take this opportunity to thank the scientific community and the IPCC for their tremendous efforts to produce high-quality scientific assessments. The report complements the IPCC 1.5 degrees special report and highlights key areas of concern with respect to the interactions between climate change and ecosystems, emphasizing the urgent need for actions to reduce greenhouse gas emissions. And lastly, I would just like to take this opportunity to highlight that the work at the Convention and the implementation of the Paris Agreement must be based on the best available science. Thank you.
Thank you very much, Sweden. I now give the floor to FAO/ILO. You have the floor.
Thank you, Madam Chair. This is FAO speaking. FAO welcomes the publication of the special report as a valuable guide for the organization's future work on ocean food production and relative socioeconomic implications. And we note that fisheries and aquaculture sector is singled out as one of the human activities exposed and vulnerable to climate drivers, echoing the most relevant messages of the FAO Technical Paper 627 released last year. The redistribution of fisheries resources in response to climate change have potential governance implications with disputes and disagreements in international fisheries management, but there are also new fishing opportunities. Appropriate responses are needed to minimize conflicts around resource allocation and management and seize the opportunity to sustainably manage these emerging fisheries. As regards adaptation, we note that ecosystem-based adaptation is highlighted together with the importance of participatory decision-making and the use of traditional knowledge. These principles are in line with those of the ecosystem approach to fisheries and aquaculture advocated for by FAO over the last decades. The adaptation toolbox described in the FAO Technical Paper 627 offers a broad set of adaptation measures and tools that encompass those described in the special report and are relevant for different scales and contexts. For example, it refers to safety at sea of fish workers who are at the forefront of weather events that add to the risks of what is considered the world's most dangerous occupation. To conclude, the special report findings and conclusions strongly restate the current and future climate change-related challenges for fisheries and aquaculture-dependent communities, but it also highlights opportunities for changing institutions, exploitation patterns, and management practices. Thank you, Madam Chair.
Thank you very much for that intervention and comment. Now I hand over to the co-chairs to provide feedback to the interventions, the questions, and the comments that we have had from the floor. The co-chairs and also the experts where possible. Thank you.
Okay, I just will make a start and then relate to authors and my fellow co-chairs. And I would like to come back to the youth statement on future developments and challenges. And just to say that we appreciate your engagement and your emotional investment very much. I think you have been causing the societal mobilization that we have been seeing after the publication of the 1.5 report. And that is much appreciated because that is a very important element in implementing the right policies. But that said, we must also emphasize that with respect to your reference to the information in our IPCC assessment reports, this reference should be factual and should not be extrapolated to the extreme. I think that would be to the benefit of a constructive discussion. So in your statement, there was one error to be corrected. We will certainly see a marginalization of the large-scale coral reefs and their services, but we will not lose the respective coral species. They will just not be able, in their places where they are currently supporting these large-scale reefs, they will not be able to do that in the future, depending on the degree of global warming. So there is not yet a report on extinction of a marine species under climate change, and this goes through different stages of abundance loss, reproduction loss, shifts in biogeographical distribution. So one has to be very careful in phrasing such statements. That said, I would like to jump to the question from Norway, to what extent is it possible to restore vegetation? It clearly depends on the coastline available and the policy will to restore those systems. A constraint that I would like to emphasize here is certainly the degree of global warming, because these organisms, as complex macroorganisms, also are highly specialized on a limited range of temperatures. They will not be able to colonize again places which are warmed beyond their heat limits, and the warmest ocean places are going already beyond the heat limits of some of those systems, especially seagrasses and kelp forests. So these constraints need to be considered. And that said, any effort to restore coral reefs will be hampered once global warming exceeds the temperature thresholds for those highly complex systems as well. And any experimental efforts to shift the thermal limits of those systems have so far not been able to provide a positive perspective, although such research is going on. With respect to the question, do authors want to complement this, Jean-Pierre?
Thank you, Norway, for the question. I'd like to provide another piece of information, is that the report says that restoration of vegetative coastal ecosystems such as mangroves, tidal marshes, and seagrass meadows could provide climate change mitigation through increased carbon uptake and storage of around 0.5% of current emissions. It shows the limits of this, but there are many co-benefits, namely coastal protection from erosion, improving water quality, benefiting biodiversity and fisheries. So a relatively low efficiency compared to the global carbon emissions, but a lot of co-benefits which have been highlighted in this SROCC report.
Okay, thank you. Maybe for the sea level questions and associated uncertainties, I would like to relate to my fellow co-chair, Valerie.
Thank you. So in the evidence assessed in this report, for a mean projected warming of about 1.6 degrees Celsius by 2100, that's an RCP 2.6 scenario. The projected rate of sea level rise by 2100 is around 4 millimeters per year, close to today's value. But the upper likely range goes up to 6, so twice today's value. For a mean projected warming of around 2.5 degrees Celsius by 2100, that's an RCP 4.5 pathway. The projected rate of sea level rise is, for the median value, 7, so around twice today's value. And the upper likely range goes up to 9, so close to the centimeter per year. That was the point of the question. So I would say that the current evidence suggests that the level of warming linked to limiting the rate of sea level rise to less than 1 centimeter per year is less than 2.5 degrees Celsius.
I'm aware of time, so I'll just pick up on 3 issues. Calling out the representative from Yango, I think you reminded us of the danger of a less diverse and more dangerous future and the importance of keeping science at the heart of our forward planning, so thank you for that. Antigua and Barbuda, you raised the important issue of financing and how the substantial investments that will be required could be freed up. This is a point that was highlighted in the special report of 1.5, when the assessment pointed to the major system transitions that would be required if there was an intent to achieve a 1.5 degree future. And that report spoke to the fact that current flows of investment would have to be redistributed and altered. The detail of that, however, was not provided. There is work being done in the context of Working Group 2 to begin to look at what that might mean at a regional level. So that's something I think we will have to wait for the main assessments to deal with. To South Africa in terms of how best to ensure that the information we heard today in its diversity and indeed its density could be better communicated. Again, this is something the IPCC is working on, determining how best to take this information forward so that it can empower and enable, as highlighted in the Special Report on Oceans and Cryosphere, as an important response option.
With respect to the question asked by Suriname, I can currently not find an answer in this report, so your question is probably, and the process, the relevant process, has probably not been assessed in this report. It's a very specific question, and I would like to encourage you to join the review of the regional chapters that should be addressing these issues and make those experts aware that such a process that is important for your coastline should be assessed. And there were comments by Sweden, FAO. I don't think that we need an answer on those. The comment by South Africa is gratefully received. This is the first time that we receive a comment that it's easier to read our chapters rather than the summary for policymakers.
Thank you very much, the co-chairs and also the experts for providing feedback to the questions and interventions from the floor. At this moment in time, allow me to invite Hosni, the co-chair for this session, to provide final remarks. Hosni.
Thank you, Stella, and thank you very much. And let me allow me just briefly summarize this section's presentations and comments. And I would like to say that we have presented the impacts, both observed and projections, in physical ecosystems and services, and ecosystems and services, and to the people. We have also presented the implementing responses, the challenges facing them, and strengthening response options, and then enabling conditions. The key conclusions from this presentation is that immediate action is necessary to reduce climate impacts on oceans and cryosphere. There were many questions revolving around the region-specific information, such as risks, adaptation options, its potential, and limits to adaptation, and enabling conditions. There were also questions about uncertainty in some particular sectors. And then there are questions about the literature base and data sources. We very much appreciate your questions, and we will consider them in our ongoing assessment of 6th assessment report. Thank you very much for your questions and comments. With that, I will hand back to Stella.
Thank you very much, Hosang. And from us, myself, and the co-chair, we have noted of the discussions that we have had today. They were rich, and the SBSTA chair and Hosang will be producing an informal summary report and their own responsibility early next year to advance the work of SBSTA at SBSTA 52. This report will be made available on the UNFCCC page on this event, as usual. Once again, I thank you for your participation, and it was my pleasure to be with you this afternoon. Thank you very much. Have a lovely evening.